Okay, cool. Live. We're all live. Hmm. Oh, cool. We got our first person joining in. Watching from the Philippines. Welcome.
Welcome.
Hanzo. How is the weather over there in the Philippines? Anton is in Bulgaria, and I am in Florida, in the United States.
People from all over the world now.
Yeah, exactly. Cool. So we got somebody joining from Illinois. Welcome from Illinois. Is it snowing in Illinois? Because I heard that there's a lot of places that are already getting snow. Oh, we got someone else from Bulgaria.
Oh.
Georgie from Bulgaria.
Welcome.
How do you say hello in Bulgarian, Anton?
Zdrasty.
Zdrasty?
Yeah.
It's very, very similar to Russian.
Yeah.
Russian is Здравствуйте.
Yeah, it's almost the same.
Yeah. Zdrasty, Georgie. We got someone from Poland. Welcome, Iwa from Poland. We got someone from Omaha. Welcome.
Not snowing yet. Yeah.
Welcome, everyone. Yeah, we will be starting in a few minutes. We're just going to let everyone join in. It's early morning in a lot of parts. In Europe, it's obviously not early morning, but in the US, it's early morning here. So we'll let everyone wake up, get their coffee, join in, and then we'll get started with the presentation from Anton. Oh, from UK. Awesome. Welcome. Welcome from UK, Queenie. I went to London a year ago, and I loved it there. It was my first time. It's a wonderful, wonderful city and wonderful country. Anton, how's the weather in Bulgaria?
It's really hot today. It's 35 degrees Celsius. So.
Oh wow.
Yeah. It's still summer.
Yeah. You guys get the 4 seasons in Bulgaria?
Yeah.
You guys get a heavy winter?
It depends. In the last few years, there wasn't so much snow, only in the mountains. Here in Sofia last year, we had a snow only for 2-3 days.
Oh, okay.
But it really depends where, There are some parts in Bulgaria that they have more snow.
That's cool. Makes sense.
Yeah.
I know there's a part in Bulgaria that has like a beach, right?
Yeah,
It's a very like touristy attraction.
we have a really huge seaside, you know. Many
Yeah.
people right now are going there, especially in the south.
That's cool. What's that area called?
It's on the Black Sea, so we have many areas, and one of the biggest seaside resorts in Europe, Sunny Beach, with huge,
Sunny Beach.
yeah, Sunny Beach, like from the sun.
Yeah, makes sense.
It's like a party hub, or at least it was. This year, not so much because
Yeah,
there are so many tourists. But basically, most of the Bulgarians are going to Greece or to our southern part of Bulgaria on the seaside because there you can find a lot of small villages with houses and stuff.
That's really cool. Yeah, one of my really good friends from one of my old workplaces, he was from Bulgaria. He would show me pictures of the beach areas in Bulgaria, and I was like, oh, I definitely got to go one day. Seems really nice. Cool. So we're having a lot more people join. People from all over the world. We got Romania, New York, Turkey, Serbia, India. Super awesome. Yeah, welcome everyone. This is so cool to have everyone from all over the world joining in. So exciting how we can all come together for like to learn some specific topic, you know.
Yeah.
It's kind of cool that we can go out together. India, UK, awesome, US. Awesome. Great. We're gonna wait a few more minutes, everyone. So some areas of the world it's early right now, so people are probably waking up. So we'll just give everyone a few more minutes, maybe 2 more minutes until 8:05, and then we'll start the presentation. Right? Early birds get the worm, so you got the early watch the presentation early as well.
You know, I'm drinking my third coffee, so I can start talking quite fast.
Okay, Anton, finishing up this day. Anton, someone said they ordered your design patterns book, and it's awesome. Great job.
Oh, thank you.
Yeah, talking about that. Yeah, I also read Anton's book. Didn't finish it 100% either, but I totally agree. It's fantastic. Anton is one of the few people left in the automation space that I actually learned C# stuff from. I've been doing C# so long that there are few people left for me to learn from.
Actually, I don't know whether I told you, but I started also blogging about Java. So yeah, I think I plan to maybe release early next year a Java version of the book. So yeah, here and there, I hope that I will have the time to do it.
That's very cool.
Yeah, because it's a little bit different. Like they're similar, but yeah, there are some specifics.
Yeah, that's cool. Yeah, I mean, I think pretty much all your patterns apply to all programming languages. Just your code samples are in C#. But yeah, they translate pretty easy to Java.
Yeah, I think the same. Like I needed like 2 weeks, I think, to get used to the language with all the specifics and more hard stuff. So it shouldn't be hard.
Yeah, curious now. What do you think of that transition from C# to Java? Which do you prefer?
You know, I wrote you an email about it to ask you about books, but actually right now it's really awesome that there are a lot of new courses on Pro site. They have this Java path there with, I think, 20 courses. I watched all of them, like 100 hours spent on watching videos on Speed 2. Then I read 2 books about it, and then I'm ready to go. You know, there are some differences because I wrote Java 10 years ago, and since then there are a lot of new versions. Like I used Java 2 or 4, I'm not sure. Now it's 14. And but there are some differences, you know. It's not so one-to-one transition to C Sharp, because, for example, in Java you have this stream API, which is like the link in C Sharp or similar, but in streams in C Sharp are something completely different. And if you are just thinking what a stream is, if I haven't watched the videos, then I was pretty confused at the beginning. And then it's a little bit more challenging because you have more tools and like frameworks and libraries to choose from, because it's an open source world from a longer time. Like, for example, Maven and Gradle, you need to choose the right like build tool and stuff. And this is why, because I'm going to port maybe Bellatrix to Java 2, but I need to know all these low-level details in order to choose the right combination, you know. And yeah.
That's cool. Yeah, totally agree, man. All right, cool. Well, let's start jumping into it, because I think all the early birds have joined. Welcome, everyone. We're joined here today with Anton Angelov, and we're going to be talking about design patterns for high-quality automated tests. If you don't know Anton Angelov, he's the CTO and co-founder of Automate the Planet, inventor of Bellatrix test automation framework, and Mesa distributed test runner. Anton has 10 years of experience in the field of automated testing. He designs and writes scalable test automation solutions and tools. He consults and trains companies regarding their automated testing efforts. Part of his job is to lead a team of passionate engineers helping companies succeed with their test automation using the company's Bellatrix tooling. He's most famous with his blogging at automatetheplanet.com and has given many conference talks. And yeah, he's going to be presenting on the design patterns for high-quality automated tests, which he published a book a few months ago. And I personally have looked at the book and read it, and I liked it a lot. And as I was mentioning earlier, Anton is one of the few people that I can still learn from in terms of C# test automation and test automation in general. So we're going to get some really good information here. So with all of that said, I'm going to hand it over to Anton and present.
Okay. Hi, everyone. Let's get started. To be honest, usually I did this webinar for Ukraine and one more time in another country. So I could, to be honest, I'm just, usually the presentation is structured as the structure of the book. However, I know many of you are more experienced than, like the middle level of test automation engineers. This is why I cut the beginning of the presentation, where I usually present some kind of a theory about, for example, what are the differences between library and a framework, and discussing solid and other principles. And this is why I will just go directly to some more code examples right on. Just before proceeding, with the code and everything, I just want to discuss first why our tests are failing. Just in a short time. Usually, our tests are failing, and this is the good way, and this means that our tests are working when they catch a real problem in our system, a bug, an issue. However, many often, usually, tests are failing because test environment problems. Imagine that your site is, for example, if your tests are about a website is deploying and then your tests start failing. This is the test environment problem. Or, for example, another problem that a couple of years ago happened is that my colleagues were doing wall testing during the execution of our UI tests. And then the websites were so slow that all of our automation failed, And there are many more examples about test environment problems. So you need to keep that in mind. However, many often we'll talk much about that in the presentation right now. There are problems actually in the tests, the term flaky tests, meaning that sometimes your test is passing, sometimes it's failing, and usually this is due, some kind of for example, hard-coded pauses or other problems, timing issues. We'll talk about that. I will give you an example how a few ways how we can solve that. Then another important thing is, and this is, I think, one of the huge problems, if you write your test in a way that your tests depend on each other. For example, I will give you an example later on. For example, first test needs to log you into the system, and then the second test is making a purchase, and then in the third test you realize that you are logged in and have the purchase and need to go to your account to check whether the order was successful or not. But imagine if the first test fails and you cannot be logged in, then the other two tests will fail too, because they depend on this first test. And usually this rule of writing your tests independent from each other. I will give you a few tips later on how probably we can solve this in a better way. And other two reasons are, for example, if you have a hard-coded test data, that makes sometimes really hard for maintaining the tests, especially porting into different environments. And the same, if you I'm not a big fan of the code duplication. This is why I wrote the book. Usually through design patterns and arranging the code, you can reuse big parts of them and just fix or refactoring your stuff in a single place. This is a big part of what I'm writing usually. You'll see a lot of examples. So let's go straight on to a demo. I will just give you like a hint what we will talk about in a minute. I will present to you, I don't know whether you know, but I wrote a framework called Bellatrix. It's like a framework that allows you to automate web, mobile, desktop API. It's open source. I will just give you a short demonstration from it, one of its features. This is a sample test from there. One of the cool features about troubleshooting is that basically if you use this kind of attribute on top of your tests, you can specify that you want Bellatrix to record a video and keep it if your tests are failing. And this is working, by the way, cross-platform, meaning it will work on Linux, Windows, Mac. And how we do that, actually, like in 10 minutes, I will present to you the observer design pattern. This is a pattern that allows us to write plugins. In this case here, I wrote a plugin. What does it mean, plugin? Here in the C# space, we usually use two frameworks for unit testing. One of them is called MS Test. It's built by Microsoft, and NUnit, which is another open source framework, quite popular. And our plugins, they allow you to, as you know, in Java or in C#, you have logic that can be executed before the test, after the test, before all of the tests here in the class. And our plugins actually allow you to execute logic before this test initialize phase or after it, or before the test cleanup and after the test cleanup. Basically, in the pre-test init phase of this plugin using the observer, we are executing all of these plugins, and basically we start the recording, and then in the test cleanup, we check what is the result of the test, whether it failed or not. If it failed, we just stop the recorder and save the video. Otherwise, we don't keep it. And how this works, let me show you. So this is my test here in the test project. Then here, first I need my plugin. I will show you a diagram in a minute. Just for now, yeah, I will explain what video recording I use. You can download the whole source code. You can use it whatever you want. It's Apache version 2, so it's open source. You can go to Bellatrix solutions to download it. So here is my plugin. I will not explain it right now. I will do that in a minute. But basically here, this video workflow plugin extends this test workflow plugin, which is my based observer class. And here, as you can see in the post initialize, this is executed after my initialize code. And here, basically, I start the video recorder. I start to record it. And then in the post test cleanup, as I told you, basically I check if the test failed or not and save the video. So about the video recorder, here I have a separate project because I wrote the plugin in a way that, for example, if you want to use another recorder, that's fine. Initially, I wrote another recorder that used another Microsoft technology, another video recorder, but it was deprecated and it worked only on Windows. This is why I switched to FFmpeg, which is a command line recorder, which is open source. You can download it. Basically, the way we use it is that here in the project, I created a NuGet package, Bellatrix FFmpeg recorder, which basically just copy paste, depending on your operating system, the executable of the recorder. It's copied in the bin folder, and then when it's in the build folder, this recorder here, which is a C# wrapper of it, as you can see here in this record method, when I specify where I need to save my file, depending on the operating system here, I use this runtime information part of .NET Core to get the operating system, since the different versions of the recorder use different video formats for the operating systems. So I built here in this method the full path with the right format. And then, as you can see here, I create a C# process and start the whole process from command line in a background. And these arguments, they are different. I get it from their website through experimentation. Depending on the operating system, they use different codecs here with a few different parameters. I just played with them a little bit so that the video is not so huge, But if you want a better quality or better frame rate or whatever, you can change all of these settings here, which is great. Even if you don't use the observer, you're free to use this video recorder. It's really great. You can integrate it the way you like. So I created here another class for, it's like a helper for working with processes in C# and starting the shell and everything. Again, it's not part of the presentation, so it's not so important. You can, it's not like a design pattern. And basically, after the end, here I implement a disposable interface, and I just basically kill the process, and then on a kill, it is basically saving the file. This is it. And again, through the observer pattern here that I will present in a minute, basically we just check based on the outcome of the test. This is coming from text context from MS test. I get whether the test passed or not. And I use also reflection. The reflection is, a library in C# and in Java where I can get information runtime for my classes and methods, etc. And through reflection, in this plugin here, I can get the custom attributes and the name of the methods and everything that I need, this meta information, so that I can decide whether I need to record everything. So yeah, this was just a short like warm up for the next few things. I will just go through the way the book is structured, because it's built in a way that we're starting with the more easy stuff and then talking about more advanced patterns. So first I want to speak about optimizations of the tests and stabilizing them. For this, I will directly show you the demo. Usually in the book and in many presentations and articles that I write, I use this, our demo website, Demos Bellatrix Solutions. And it's like a simulation for a real shopping cart. And it's cool because it's a real shopping cart. And if you see here, when I click add, it uses AJAX, asynchronous requests. It's not loading the whole page. And usually this type of stuff a little bit harder to automate. And so my demo is I add something to the shopping cart, then I navigate to here. I use a coupon for a discount. As you can see here again, AJAX, it's happening asynchronously. If I update here the shopping cart and update again, loading screen, asynchronous, sometimes it's passing for 1 second, sometimes for 5, it really depends. And then when I click to checkout, I need to wait here for this to load. I can preview the information and place the order. This is basically my first test that I want to automate. So also about the book, you can go to Automate the Planet GitHub, and here design patterns for high quality automated tests, C# edition. It's a public repository. You can download the whole source code with all chapters. It's free. So these are the demos that I will present right now. So for the first chapter, actually the second, stabilized tests, I will show you how usually people, juniors, write this kind of tests. This is the test that I presented to you right now. Yeah, sure. Let me. I'm not sure how to use the chat, but later on I will give you the link to the repo. Yeah, later I will give it to you, don't worry. So here in this stabilized, this is chapter 2, I created a few versions of the same test. I just wanted to walk you through quite fast. As you can see here, I use no patterns, no classes. I'm just placing everything in a single file, like most people do when first they learn C#. And in order to handle all this asynchronous stuff that I showed you with the loading screen, here I did it in the most simple way. I just use it thread sleep, which is like hard-coded pauses. Here I sleep for half a second, 2 seconds, etc. And also here it's quite unreadable because directly in the test I find the elements, I click on them. There are many nitty-gritty details, many hard-coded pauses, a lot of, for example, here instead of just having a method called type, I have clear, thread sleep, then send keys. It's quite unreadable. And this is how usually people write it. Quite long, like 2-screen long. Ugly. So I will show you now a few other ways that maybe most of you know, especially if you attend to Nikolai's courses. We can use this explicit and implicit wait. As you know, implicit wait is when you use this global timeout here, but sometimes this is not so useful because there are places where you need to wait for 30 seconds, but if you set this global timeout, this means that every time you will wait for 30 seconds, but sometimes 5 seconds it might be good. And this is why I don't like the implicit waits. Instead, it's much better approach to create helper methods like here to have this, this is called explicit wait. And we use a helper library called WebDriver wait. In order to use it, you need this .NET Selenium Extra Suite helpers. Yeah, right here, I created two helper methods. Not so good name because, you know, it's not a good practice to have end. This means that the method is doing two things, but still just ignore that for now. So let's call that wait and find element. Basically, you provide the biolocator here as an argument, and then we create this WebDriver wait. And this wait until, the thing that it will do through this lambda is that it will wait particularly the exact time that you need until the element is visible or not, which is the thing that we need. Don't need hard-coded pauses, don't need this global timeout. Instead of using driver find element everywhere in the tests, right now I change the code and I use this wait and find element. And this every time will wait until my elements show up. And I even create one more helper here that it's called wait to be clickable. This is coming from this Selenium Extra Suite, this expected conditions. If you hover, you will see that this is a func, this is a delegate. Basically, this will wait until your element is interactable and clickable, because sometimes you're not allowed to click on an element. For example, when you have a spinner on it. And this is why if we go here to reference and click, here when I need to click on the update card, I will wait for this element to be clickable and then I will click on it, which is great. This is one way to solve this problem with hard-coded pauses, to use explicit waits and helper functions. This is the basic stuff. However, there is maybe even a better approach to make, because the API is still a little bit ugly. You have these clear send keys. It's not readable. It's hard to extend. Basically, you cannot extend it the right way. You just need to go to every test to add your own logic. Imagine that you want to add some kind of a logging. Right now, you cannot do it. You need to go directly to the test and do it. And this is how these two problems can be solved with the decorator design pattern. What is the decorator? You can think of it as a wrapper. And basically, first you have this decorator base class that defines the interface. The good thing is that in this interface, you can design the API so that it's more readable, as you will see in a second. And basically, you have this component wrapped object. In our case, this will be iWeb element or iWeb driver. And we'll make here the API a little bit better. And then you have these concrete decorators where you implement this base class. For example, here we will create our web element decorator, where we will implement, for example, a type command where you type, and inside of it we'll first clear, then we'll wait, then we'll type the text. But actually the API in the end will be much more readable, as you'll see in a second. And the good thing is that we can nest the decorators. As you will see in the first decorator, basically I'm calling directly iWeb element or iWeb driver. But in the second, I'm just calling my second decorator and I'm adding the logging. I think you understand it much better when we see the examples. Again, here in the stabilized test demos, in the third version, let's look. First, for the driver, this is our abstract class from the diagram. I designed a few, public methods. I ignored a few. And here I have a method like a start. This is like a factory method based on, as I will show in a minute, where I have an enumeration that defines the browsers. Depending on which browser you pass, then this factory method will start the appropriate, browser. And by the way, I will try to answer all of your questions in the end. I hope that we will have enough time. Then we have this go to URL and find element and find elements. If we go to the implementation of this in this WebDriver here, as you see, there are two things. First, we implement this abstract class, and the second thing is our wrapped object that we basically it's here. Also, yeah. Why? It depends how you implemented it, but keep in mind that here we basically initialize it in this factory method. This is another design pattern called factory method, where basically, as you can see, we override this abstract start method, and here we create the proper driver based on this enumeration. And here we also initialize the WebDriver weight. And then we just call the wrapped WebDriver here in our methods. As you can see here, we improved a little bit the API. Instead of just typing navigate.goToURL, we use directly goToURL. And another important thing is that here we use this find element, but actually inside it, hidden from you, we use WebDriver wait first to wait for the element to show up, to be visible, and then we initialize it. As you can see here, as I show in a minute, we basically initialize the different decorators here for the element as well. And no, by the way, this API for the WebDriver wait, it's not obsolete. It's obsolete from the particular, I think, package. It was previously here in the support NuGet. Right now, it's just a new project. Yeah. So here in the find element, we wait for the element, initialize the element decorator. What is the element decorator? The same way as here, we have a basic abstract class, the base class, where there is a new thing. Here, our decorated element will know how it was located, which is really great. Then instead of having this method send keys and clear or whatever, it will have this type text, which is much more readable, and easy to use. And we'll have only these few, properties and methods. Then we have the implementation of it, the first implementation, where here we use composition instead of, child classes and stuff. And here, basically through the constructor, we initialize the wrapped driver and the wrapped web element. And basically we call this wrapped element everywhere. However, again, here, for example, for the click, we use this wait to be clickable so that you're sure that your element is clickable and interactable at this moment instead of throwing exceptions. It's the same implementation from the helper. I copied it here. And the type text that improved a little bit the API. Here, first you clear the text and then you use these send keys to type the text. And now the power of the decorators and the whole meaning of it. If I want, for example, right now to add logging, for example, I want to create a logging to walk to the output, what I typed or which element I click with what kind of a locator. Instead of just going directly here and editing the code right here, this means that if we follow solid, this means that this is a bad practice. Once you wrote this code, it should be written in an extendable way. This is how the decorators help us. Because if you directly go here and edit the code every time that you want to add additional functionality, this is bad. Because every time you can introduce a regression bug. This is why, instead of doing that, we create a second decorator that, you extend again this element decorator here. Basically, we provide here, again, as a composition, we provided this through the constructor. And we basically first call our base action and then add the logic here. It's like a kind of a recursion. It's not a recursion, but basically you call the inner element and you can add on top of it as many decorator as you like. If you return here to the WebDriver, if you see first here, we create our first decorator, the web element, and then we create the second one. And here we provide, basically we nest them. And you can create this kind of nested decorators many times. If you need additional logic, you can create one more decorator, add it here, and paste here the second one inside its constructor, and it will work like a charm. I did the same with the logging driver here. Basically, here in the constructor, I accept the abstract class, provide it to the base constructor. I call the base of this nested thing, and here I add the new logic, which is some kind of a logging. So this is the way how you can achieve this improved API. As you can see here, first I directly create the logging driver and then nest the WebDriver decorator, the two decorators, but I can create one more. And then I use this factory method here to start the browser. And then the API stayed almost the same. As you can see, I use driver find element, almost nothing changed compared to the version 1, but actually here inside this find element, I will wait first for the element to show up, then I will return it. Instead of same keys, clear and pauses, I use this type text, which makes the test a little bit more readable. The click is improved because I will wait for the element to be clickable, then I will click it. And if I want to extend it, here also when I execute the test, this will here I will wait for first to be clickable and then I will click it. Yeah, about the test dependencies, here in this first demo, my tests depend on each other. It's basically the same thing that I explained when I was talking about the test dependencies. The best possible way, I don't have an example right now to show you, but the best possible way to be sure that your tests are not coupled, not depend on each other, is to use, for example, if you're automating mobile or web, usually, if your website is using newer technologies, usually your website like this one here is basically underneath is using web services APIs. One way how you can solve this problem is to use factories to, I think I have one article about this, I think here in design patterns section, I wrote an article about generic repository. Basically used, for example, if you have access directly to the database, you can use a framework in C# like entity framework to create and use this kind of a repository. Here in this article, basically the thing that I do is that I create special users or clients that are used to log into the website, to the demo website, and every test is using a unique user instead of using a single one, or depend that your, for example, login is working, or going through the, through the registration form. You can check the article and what the generic repository design pattern is. But basically, another way here, instead of going every time in your website to, going through the login, because you need to log in to check your account. Of course, you need to test your login form, whether it's working or not. But you will have 10 tests, for example, or 20 tests that will test the login form with all kinds of, variations of boundary value analysis, etc. And this is your test suite for the login form. But then for the rest of your tests, for example, for the tests of your account tests, you don't need to go each time through the login form. Instead, if you go here to DevTools and go to application and go to cookies, there are ways that you can generate your cookies here. Usually this is much better to create. This is the way I usually automate login forms, and this speed up the test a lot. Basically, you generate your authentication cookie, you set it through WebDriver, you reload the page, and you're already logged in with your unique, user. And this is one way how you can solve this type of dependency. For one project that we right now, my company is working on for American company. Basically, we use this repositories, like the one I showed you here, but we don't have access to the database directly. Instead, their website is built in a way that they have, I don't know, maybe 100 different APIs behind the scenes of the website. We basically just wrote a wrapper in this kind of a generic repositories to call their APIs for creating products, orders, support tickets, whatever you want that you need. And we use this predefined data to execute some of the tests. This is our test data. Instead of, going each time to submit a ticket and then try to modify it. This is the way how you create brittle tests. This is why you need half of the job is to use the proper framework, but then big part of it is to have these repositories to set up the data and use it in the proper way and to speed up the tests. I hope that I answered the question. Let's now proceed, if you want, with the presentation. So another way how you can optimize the tests and handle this kind of asynchronous requests is many times, as you know, in WebDriver you can execute JavaScript. Right here in our website, I'm using our website is using Ajax and synchronous JavaScript, and this is why there is this function. Yeah, okay, we'll stop in 8 minutes. Probably we'll need like a second and third part because I'm just 1/4 of the presentation anyway. Here. Basically, I'm executing this jQuery function to wait for all of the requests to finish, and then I'm sure that I can proceed and these loading screens are not appearing, which is a really great way for waiting for these Ajax requests. As I said, I'm not sure that we'll have the time to explain the whole pattern here, but in the second chapter, I think, just wait a second. Here is the demo. Yeah, let's open the solution. I will show you the way how we in Bellatrix here. Instead of, if I go to the test again, here instead of every time starting a new browser, right now, again, like the video recording, we wrote a plugin using the observer design pattern for, like behind the scenes, we have similar factory method, the way to the one that I showed you before. But basically, I pass here the enumeration from my attribute here, and I added additional behavior where, if I want, I can reuse the browser if it's already started. Every time for the new test, probably I can write a logic where I can clear the cookies or I can, have a clear session. But basically, I'm reusing the browser because I observed that many times you lose a lot of time for, starting and closing the browser every time, especially, for example, if you use Firefox, this is up to 10 seconds per test. Imagine how many seconds if you have 3,000 tests like we do in one of our projects, how much time you will save if you reuse the browser. Or you can just, for example, if the test is failing, the way we build the plugin is that it will basically close the browser, but only in the case of test failure. And again, we use this observer pattern to create such a plugin. And how this works is basically we have an interface called I test execution subject. This is the way it's, the name in the pattern. Here I have these methods again, like in the base class before, that define this pre-test initialize phase, post-test initialize, etc. Then I have this kind of implementations for, again, MS test and main unit, because we have both implementations that they implement this kind of thing. And then in the base test, basically I'm, as I will show you in a minute, I call this pre-test initialize before and after the actual test initialize phase. And then in order the plugins to work, we have this base test behavior observer. Basically, this is the base class for all plugins, where here I have protected methods for this pre-test initializes phases. And basically here I'm using event in delegates in C#. In Java it will be a little bit harder, because there, as far as I know, there are no such thing. But again, there is a different version of the pattern there, so that you can write it. And let me show you the code, and you get it, I think, from the example. Here in version 5 of the same tests, in this browser infrastructure, this is my iTest subject. As I said, here basically we pass the MS test context in this pre and post test initialize phases. Basically here I have a list of all of my plugins, and I can add and remove them. And basically I'm for reaching all the plugins and execute the pre-test initialize phase, you see. And the cool thing about this pattern is that I don't need to modify my base test here. As you can see, this is my base test for MS test. I have this current test execution subject that is basically, if I go here to initialize observers, I can just create a list of all plugins that I want to execute here. In this case, I'm having only one, the browser, but for example, for the videos and all of them, I can add more. And then here in the actual test initialize with the attribute, basically I'm executing pre-test init. And if I navigate here to the actual implementation, basically I'm for reaching all of the plugins logic in the pre-test init, which is basically, if I go to my browser launch plugin here, as you will see in its pre-test initialize phase, I'm basically again using reflection to get the browser information from the attribute. Then I get whether I need to restart the browser or not, and then I restarted it, and then I close it. It is the same happening here in the post-test cleanup. The power here is that I can add up much more plugins here to the base test, but without modifying the core logic here. This is making my, it's really powerful, because I don't need to modify this core logic here. I guess we're almost out of time, so you can, Nikolai told me that maybe it's time for questions. As I said, I can talk much more about it, but maybe we'll create a part 2 if Nikolai's okay with it. Yeah, exactly. This plugin architecture, it will allow for this open close principle. This is correct. So, Nikolai, do you want to discuss something or to answer some questions?
Yeah, sure. Thanks so much, Anton. Thank you for that presentation, and definitely can have part 2, 3, and 4 if that's necessary to just finish the discussion. I know you have so much information from the book that you haven't even covered yet. Let's start tackling some questions.
Mm-hmm.
Scroll up here. One thing I don't know if you can do, I saw people wanted the URL of your code. I don't know if you can just drop that in the chat for us.
Yeah, I can share the GitHub repository, right? Yeah, again, the framework is free and open source. You can download it from here. This is the first website. Let me see how I can add it to the chat.
Yeah, you can probably in the bottom right. You should have it. I've never been a guest. So, okay.
Yeah, I'm not sure that I can write to the chat. Anyways,
Oh, you can? Oh, I can.
I can say the feedback, but I cannot write to the chat. I don't know. Anyway, I will send you the links, and you can send it in an email if you want.
Yeah, well, and we can also see it on the screen. Right?
Yeah, this is, just GitHub automate the planet, and you will find the repository.
Perfect.
It's right
Sounds
here.
good. And just to clear it up, this Bellatrix solution and code is in C#, correct?
Yeah, it's in C#. We have a plan maybe for next year to have it on Java too. But since we are doing a lot of trainings right now, I'm just trying to focus on the trainings that we do about test automation. This is why maybe we'll just pause it for a moment, this effort for the Java stuff. But right now it's open source and in C#. Yeah.
And I'm sure if one of you wants to re-implement in Java, Anton.
Yeah.
Okay. All right, cool. So first question for you, Anton. Parul asks, I've observed people using fluent explicit wait anywhere they feel like. Would you tell the exact difference between fluent and explicit waits?
Fluent.
If you don't know, I can talk about it. Anton.
Yeah, you can.
Yeah, fluent waits are actually a concept in Java. We don't have it in C#. In C#, the equivalent is what's that class that explicit waits inherits from? I always forget. I think it's like, I forget. But there's a class that explicit waits inherit from. But fluent waits are basically just, it allows you to basically like customize the polling interval, the message. The default wait. It's the equivalent. In C# we have a default wait. In Java they have a fluent wait. It's just a different interface, but it basically allows you to set your polling interval, your message. To be honest, totally useless. I've never had to use it in my life. Kind of just like Anton, I just use a WebDriver wait. WebDriver wait with expected conditions, or your own custom conditions if you want, and that should be sufficient. Do you agree with that, Anton? Have you ever used the default wait?
The default wait? You mean the implicit wait?
No, I mean the default wait that you actually instantiated and you default wait class and then use that as an explicit wait.
No, I haven't.
Yeah, it's I don't know why it got introduced into the world, but don't worry about the difference between a fluent and fluent. Technically, fluent wait is an explicit wait. So when we say use an explicit wait, what that means is use the WebDriver wait. Both are the same in the Selenium NPI in Java and C#. So how Anton is showing right now, use the WebDriver wait, and then just use expected conditions or configure your own as Anton.
Yeah.
Let's see here. Oh, I asked. I said how there's two use cases for thread.sleep. One person did give, and there's only two use cases appropriate. I don't know if Anton will agree with me or not. One of them someone said was correct, which is a forced wait, correct. So that's if your application actually has a behavior that forces you to wait for a specific period of time before you can proceed with an action. For example, like an exam. If you sign up for an exam, you have to wait for 1 minute before the exam can start. In that case, a thread.sleep is absolutely perfect. And then in other instances, actually, Selenium can sometimes be too fast to type into a field in certain applications, in which case what you have to do is break up your string that you want to type into an array of characters, and then type one character at a time, and in between each one, sleep for like 100, maybe 200 milliseconds. Those are the only two appropriate use cases of a thread.sleep. What do you think about that, Anton?
I think I'm just searching for one example from Bellatrix where I used it. It's in the implementation of some of the elements here, because we have a different implementation for each, for each type of element, instead of using this single interface iWeb element, here in order to make the API more user-friendly, we have these like decorators for the buttons for each type of the element. Here we have many of the elements that they have different methods and properties, etc., and different implementations. I think in one of them, I used to thread sleep, for example, to sleep for 200 milliseconds so that the action may go the right way. I mean, because otherwise WebDriver was always failing. And I think this was happening for HTML5 controls where, WebDriver is not so good in working with them directly. When, for example, have a mount control or whatever, some kind of this here, more complex controls. And in order to work, we use JavaScript, and set the value attribute or use JavaScript to set it. And sometimes you need thread sleep. I mean, in this edge cases, but it's really, really rare. But I agree with you and about the thread sleep. Sometimes it's useful. I'm not saying that we shouldn't use it at all. But if we have these built-in ways, it's better to use them, like the fluent weight or explicit weight in particular.
It's an exception more than the rule.
Yeah, exactly.
Don't default to thread. Have it as a last resort. Maybe kind of like the Actions API in Selenium as well, keyboard actions and stuff. If you must use it, it's an absolute last resort. But if you can avoid it, do your best.
Yeah.
Thanks, Anton. Let's continue here. So someone asks, assertion in page classes, yes or no?
Yeah, I'm for them. Let me check. I think in this test readability demos here, I'm not sure whether it's here or not. Let me check. If you open the solution here, I think in the maybe API usability demos, I have 10 versions of page objects, and my preferred one is to use, at least in C# in Java, there isn't such a thing like partial classes, but I usually prefer my assertions to be inside my pages. If there is a need to, like here, I have assertions. Here it's actually not a partial class, but anyway, on the blog, on Automated Planet, there are separate articles about them. You can find them, a lot of different implementations. But I prefer my assertions, especially if I'm going to reuse them in many places, to be placed inside my pages. Just usually I prefer to be in a separate file. Usually we can do that through partial classes or like here through composition. Like, for example, here I created like properties for elements and the assertions, and I use them through composition like here. Again, there are at least 10 different variations how you can do it. It's a matter of choice, and usually there are different pros and cons. Actually, this is one of the big topics in the book, how to choose between this kind of, when you have this kind of characteristics that you can achieve for the framework, like readability, maintainability, speed of the tests, extendability, all of them, there is a balance, and you need to choose properly which one you want to achieve, and then you can choose which variation of them is good for you. Yeah.
Awesome, thank you, Anton. Let's see if we got like a few more minutes left. This should be over. We can go a little longer. It's a nice thing about that stream. So I think you briefly spoke about it, but you can cover it in a little bit more detail. Brooke asks how to handle expected conditions since it'll be obsolete, which I know you have to misconception.
Can you repeat the question, because
how to handle expected conditions since it will be obsolete?
As I said, it's not obsolete. It's just moved to another project. Actually, the maintainer of it, Jim Evans, wrote an article about it in his blog, that just he is moving some of the, for example, page objects project was moved again to a different NuGet project, as well as these expected conditions. In order to use the expected conditions, you need this NuGet package. This is the name also of the project in GitHub. It's called .NET Selenium Extras Wait Helpers. This is where you can find this expected conditions class that you can use with these delegates and helpers. And the projects were separated so that they can be easily find their own maintainer on GitHub. And this was the reason that they were moved. But they are not deprecated, they exist, and they exist in Java too and other languages too. Yeah.
They're deprecated from the Selenium NuGet package, but they're still alive in another NuGet package.
Yeah.
They will continue to live. They're very good.
Again, I can show you code that you can write it on your own. Here in Bellatrix, for example, we have this code ensures, which is like a logic where you wait for a particular condition to happen. Just give me a second to find the right thing here. Actually, it's called until. I wrote about it in the book too. Here, basically, this is a logic like an extension to, for example, here, this until be visible. It's basically, instead of using this expected conditions, I wrote my own function here for doing the same. You can write it like, you can download this or you can write it yourself. This is my like implementations of it. As you can see, it's not so like easy code. It's a little bit more, I don't know, hard to understand. This is why usually I tell people just to use expected conditions, because they hide this kind of a complexity, you know. Again, here I wrote my own, for example, for has style. This is like we get the style attribute from the element, and I wait for a particular style to appear. This cannot be found in these expected conditions. Yeah.
Yeah, 100% agree with Anton. You guys can see that if you were to write your unexpected conditions, it can be frustrating and a lot of work. So just let the smart engineers of Selenium handle that work for us. They know what's going on there, and let's just use the work, and we don't need to reinvent the wheel. In some instances, as Anton here showed, element has style. You need to create that, but no reason why you can't add that to the expected conditions in the package. Cool. Let's do the last question here, Anton. What would be the first step to start a test automation project if you had the complete project and manual test suites, cases, documentation? Sounds like they're asking what would be the first step to start a test automation project from scratch if you have manual test cases automated.
Okay, so first, I don't think that all of the manual test cases should be automated. This should be, you should know that. Then the second thing is that you need to first check all of these manual cases, whether they're relevant or not, because many times if you haven't spent time to maintain them, they'll be outdated quite fast. Then you need to, be sure to sit with your product owner or with someone that can prioritize all of these test cases and see which of them are the most important for the end users or for your users and for the most critical parts of your application. And then, first you need to start with these most critical tests and then start automating them. And again, I propose every time to start directly to, when you start this test automation solution, to prepare this test data, from the beginning. don't try to test that dependent on each other or use the UI to set up the data or anything. Just even if you don't have the knowledge how to do it, like 10 years ago, I just asked my developers to help me to build this first test automation solution to prepare the data and to set up the data and etc. You know, usually they are quite helpful. They will help you to set up the data, to use the API. They will show you, you will learn new things of new libraries, etc. And when you have this test data, it's the whole process is quite fast when you start writing and write the test in the proper way and not depending on each other. So yeah, I think these are the first steps. And if you are not sure how to build the frameworks or things like that, I suggest just to use some other open source test frameworks. There are many in Java, there are many in C#. Just use some kind of this generic framework, and your job will be to just write this layer of setuping the test data, and then you can leverage this kind of open source projects and extend them if you like. Yeah. So this is my recommendation for the beginning.
That's awesome. Thanks so much, Anton. Yeah, let's wrap it up here. Thanks so much for joining us. I hope everyone enjoyed this session. Getting a bunch of people that definitely want you back, so maybe we can do another session in the future where you can continue teaching these automation patterns. Thanks again for everyone for joining us. I know it's some places early around US, in Europe. Thanks everyone for joining us in Europe, and it was a pleasure. Anton, always a pleasure to talk to you. Everyone have a wonderful day.
Thank you guys. Bye.